Hi, good morning. This is video log entry 163. It's about 9 a.m. CST. Today I just woke up at around like 6 o'clock in the morning, and for about like 2 hours I was just kind of fooling around and doing random research and whatnot, mainly around GDB and instruction code and all that, and reading hexadecimal and actually reading machine instructions and whatnot, because it's necessary, especially if you're looking at GDB and whatnot. And okay, you don't have to understand everything about hexadecimal and being able to translate from one hexadecimal to binary, unless if you're actually writing machine code and whatnot, and for assembly and all that, because of course the computer reads everything in binary. And so I don't think it's necessarily necessary to go from hexadecimal to binary, unless you're actually writing machine code for usually a compiler, because you would want to make sure that the compiler is calling the right things. And usually for humans to read, it's better to read hexadecimal, because I don't know why I said again, it's base 16. That means it's more compact. It's even more compact than base 10, because you have more possibilities on one line, or one placeholder, which is 0 to 9. And what is that? So 0 to 9 is 10, 16. Is that F? A, B, C, D, E, F, G. No, sorry, it's F. My bad. Yeah. So, yeah. Because it's E, F, and 6. Okay, I had to think about that in my head for a second. I haven't used hexadecimal in so long yet, all the way to F. And, I was doing random stuff, and I was looking at random trivia and whatnot, and, how I think if you're looking at RGB code for, hexadecimal, then, of course, it's like red, green, blue RGB, and so you'd be able to look at, so if you're looking at, so that means there would be two, like FF would be two placeholders, because again, if you're looking at red, then that's the code referring to 100% red is 255, but if you're translating 255 to hexadecimal code for that, it's going to be FF, because it's 16 times 16 is 256, but that's 256 possibilities, but then you had to include the 0, which is one of the possibilities, which is null or 0. So that's why if you're looking at white, which is RGB 100%, RG and B being FF, it's 6 placeholders, and that's just white, and black would be just null throughout RGB, so that's 0, 0, 0, 0, 0, 0. And I was just looking at, I don't know, I think hexadecimal is kind of cool, and it's fun looking at patterns, and my brain likes patterns, so of course, because I like math, and I like learning random shit, looking at patterns. So yeah, I was looking at that, and I was, no, I didn't practice actually converting. I think it's not too bad. I don't really know if I think it's decent to kind of, it's just good to know some patterns when you're reading hexadecimal, because let's say you're reading computer code and you're looking at the jumps between each, I don't know, like if you ever heard of a program counter. The program counter is actually, it's kind of weird. I'd rather call it a program pointer, because a pointer is actually a variable that contains memory, right? Or like a actual memory, which is in hexadecimal too, pretty much, because again, it's more compact than binary, and decimal and hexadecimal is still readable enough. Of course, if you keep adding too many alphanumeric characters, then obviously it's going to become unreadable, because the human brain can only add so much, to the point where it becomes inconvenient. But I think 6 alpha characters is fine. Yeah. Which is why we use hexadecimal. I don't know if a better reason for that is, it's readability and compactability, and you want to make sure that both of those are, compactability is also readable, so it's really just readable for the human mind to be the more compact in that way. I don't know how else to say it, but yeah, so I was looking at that, and I think it's good to know a little bit of hex, obviously, like anything else, especially again, like if you're doing low level, you're reading instructions and whatnot from the computer. These program counters are going to have hexadecimal representations, and then these hexadecimal representations of that particular instruction are going to be translated binary. But if you're just looking at memory jumps, then it's good to look at the second column, because memory jumps are typically from the second column. If you kind of look at it, because that's 255 possibilities, right? So you would think that would be enough, right? you would think that would be enough for standard instructions. So that's 255 instructions, right? 256, sorry. Um, yeah, so that's I think that's enough, right? That would be enough for any kind of standard CPU. So yeah, that's why it's always good to look at the those jumps in memory and whatnot. So yeah, anyways, I think that kind of makes sense. And also, if you're looking at a jump in memory, you know, you have a 64-bit machine that's within the that's within 255 possibilities, because 64 bits are 64 possibilities, and so that means, you know, if you're looking at, again, instruction, and there's like a stack, you know, usually, I don't know how this works in the computer memory and why it initializes in a certain way, but I guess, you know, if you're calling the program counters, you know, it changes and whatnot, but I don't know how it takes C code and then puts into a stack in memory. It looks like a stack. It's definitely not in heap. So, yeah. So I don't know. I don't know how it does all that stuff. I don't know. But you know, if you're reading code and whatnot, and you want to see how much memory an instruction has, you could actually just look at the jump between the two. It looks like it, and yeah, and it's good to do that because, well, again, 64-bit machines tend to you can actually look at like how much it jumps by looking at hexadecimal and reading it that way and seeing how much memory it contains. That seems reasonable. I don't know. Yeah, I was just reading a bunch of code in GDB, and I also learned about this thing called it's a command called lay split in GDB, and it makes it easy to read the actual C code and then the assembly code, and then you running commands on there to inspect registers. Yeah, and it seems fun, you know, and you know, you can have watch points and break points. I'm not sure if anybody has used GDB before. I think people use more modern debuggers, and I've tried using more modern debuggers, and I have VS Code, so I may play around with both of those debuggers to see which one works better for me. I kind of like GDB, maybe because it's on the terminal and I could just have it on the side, and it's just the layout is really nice on this, especially when you use the command called lay space split. Lay is just layout, and then I'm assuming that you could do a lay space split, meaning that you have lay being the layout command, inputting from split or whatever. That kind of makes sense. It's just the layout of how commands are dealt in GDB, which is parsable. Yeah, so it's nice. Yeah, so yeah, I didn't really have a good reason to use this. I eventually figured out that, well, on top of like somebody on Stack Overflow, where my segfault was being where the actual signal came from, and it came from my close function, because close is actually a glibc command, and I've already talked about this, and that's where the segfault occurred. And like I said before, the segfault, it was reaching outside of virtual memory within the program, and I can't do that without permission, so from the kernel. Yeah, so yeah, and that's why and it was also looking within the scope of the project itself, and obviously it was confused, and yeah, anyways, it was kind of weird. And you know, I wish I could explain this better, but again, I'm kind of new to this stuff, and these videos help me solidify my thoughts a bit more when it comes to general conceptual things. I think, of course, like anybody that's learning this stuff would want to conceptualize it. Yeah, so, and me just talking about random bullshit about this is helping quite a bit. Yeah, I don't know. Today I'm probably going to relax quite a bit, and I'll just probably fuck around today. I mean, Saturday, so and I procrastinate a little bit, so I think I may fuck around and do some collision management today and tomorrow, and just playing around with GDB and kind of learning the ins and outs or the ropes of, you know, reading hexadecimal and machine code to some extent, not completely, because it would probably take a while to be completely accustomed to it. I mean, yeah, so oh, I was also looking at, like, there's an, what is that? Oh, are these like commands? Oh, they have an offset away from create sprite, which is interesting. I was looking at that earlier. It's like, why is there an offset? It's because, oh, it's because that's the function that it's in. So then it's calling these other functions within this, what they call it, a stack frame. So the stack frame would contain a bunch of other instructions within that instruction. From that particular call. Where is... Oh, I'm still playing. What's happening? I broke something. Oh, Jesus. I don't know what happened. I broke something. That's interesting. It just canceled for some reason. There was an error. I don't know what happened. It exited GDB for some reason. Anyways, yeah, so that was interesting. I was looking at that. I was like, I guess the reason why they do that is because it's a good reference point from that particular stack frame that you're on. So, a stack frame is basically, you have the main stack, right? And then when it calls, basically when a function calls another function, main being the main function, that's a base stack, I guess. And then they call them stack frames because these stack frames contain variable initializations, and then it may call other functions within that stack frame, and that's why they have the reference from that particular, like the base stack. Like, yeah, that kind of makes sense. And yeah, so I'm still kind of getting used to that. I don't know, like when you initialize a new stack, you would probably want, the variable initializations, the pointers to those variables, and then when you want to know the address of those function calls as well. So when you have an address, you know where to go for that particular function call, and then it would go into that the next stack or whatever. So and then when it that stack frame would be expires, then it would go back into the old stack frame to then continue its code, and then eventually that would expire. And that's why you have issues with global variables and whatnot, because these global variables within files and whatnot don't necessarily encapsulate those stack frames. So you have to be careful with global variable initialization. So if you're doing variable initialization within obviously another stack, then that variable expires when the stack expires. So yeah, it probably doesn't make sense to most people unless like you specialize in this kind of stuff. I don't know, unless you're a computer science major. Yeah, so and like actually having to explain that kind of stuff, what you'd have to have in a whiteboard too. So it's like, yeah, a PC is also a register. In this, registers are used in the CPU. They temporarily hold information for the CPU to modify before it goes into memory. So it's basically CPU memory as opposed to actual memory in your computer. And then you have RAM, which is memory, and then you have actual disk space, which is more would you say long-term memory, I guess. It's kind of like working memory versus long-term memory, essentially. Yeah, so it's cool looking at that stuff, and I never had a good reason to look at this. Now I'm reading a blog about it, and it's kind of solidifying my past understanding of what I thought it was. It's kind of expanding my conceptualization of computers, so I'm enjoying it quite a bit. And yeah, I mean, I just like low-level stuff. I don't know. I like computers, I guess. So I'll probably read some more of that, and my mind is scattered. I'm not necessarily explaining things like step by step, unfortunately. I'd have to actually, like, I don't know, if I ever try to do an information, like a formal informational video about something like this, I'd have to like write down the steps and then I think most people do. That's why they have PowerPoint slides and whatnot, right? I'd have to do the same. I like notebooks, so I'd probably just write it down, and I'd probably write down the concept that I'm talking about, and then I'd write down a list of the prerequisites to understanding that concept, and then giving analogies for more laypersons understand, and then I'd have a breakdown of those particular quote-unquote prerequisites to then understand the more global conceptualized idea of that particular idea. Yeah. Maybe I'll start doing that more often. I just like, I don't know, I like letting my brain run, but it's not always a good thing, and sometimes I had to keep myself on track with notes and whatnot, and I did write a lot of notes today. I don't know what, my brain was just everywhere today, so I had to write a bunch of notes, and I was just thinking about low-level stuff, and thinking, I was like, well, I like this a lot, so I'm going to stick with low-level game programming involving SDL to maybe SFML, which is another library, and did I talk about this already? I don't even know. I may be repeating myself. I tend to forget what I say in the earlier parts of the video because it's not structured. So yeah, I was just writing about it. It's like, okay, well, embedded systems. I haven't necessarily done anything with embedded systems other than read about it, and um, I did a little bit. Like I like downloaded a GCC toolchain. The toolchain is basically compilers specialized for their particular computer architecture. So if you, I don't know. So basically, when you install Ubuntu, the Ubuntu has to know what kind of CPU it has, and before it installs the GCC compiler for it. So, this one is obviously a lot simpler. It's, I believe it's, what is it? Oh yeah, Ryzen 7, which is an x86. X86? I think AMD is x86 64? Or is Ryzen ARM? I don't even know. Let me see. I should know this. I'm gonna ask Perplexity. Ryzen 7. It's a Ryzen 7 CPU, so is Ryzen 7 ARM? Is that a good way to ask it? I know it's a 64. I know it's a 64-bit. Okay, it is okay. No, it's an x86 64 architecture. That's a 64. x86 stands for. What does x86 stand for? I don't know if it's like Intel or something. Not Intel. Well, Intel inspired architecture, 64-bit machine instructions. At 64-bit. Yes, I mean that should be enough. That's not. Okay, yeah, of course it has a different instruction set. So yeah, I mean that's what happens basically. So the GCC has to know exactly what computer architecture Ryzen 7 is, and they probably have like a list that ties into. They probably use dictionaries or something, or hash tables for that, because then you would have to know the name, and then for it to go into that particular computer architecture, would have to know that, and then we had to get the right compiler for that. Also, I think the GCC extends out to a whole slew. It definitely understands x86 64 and ARM stuff, but I think it's mainly for general purpose operating systems. It's x86 64, and then you would have to get a potential tool chain, especially if it's a 32-bit microprocessor of some sorts. And I had to mess with that because I have a few boards that I used to play around with, development boards. They weren't necessarily an isolated microprocessor. So, or I guess you would call it a, what's the other word? Brain microcontroller, because a microcontroller typically works off of either the Harvard architecture. Harvard architecture is different from the, I don't know the exact difference, but I know there's a Harvard architecture and then there's a von Neumann architecture. I know the von Neumann architecture is a data bus directly to the CPU. It's one data bus and CPU talks to that. But I think the Harvard architecture distinguishes its ROM from RAM. So you're going to have like read-only memory in a different place in that microcontroller. And then you're going to have the CPU, and then you're going to have the RAM, rapid access memory. And rapid access memory can be read and write, but ROM is read-only memory. So I think that's the Harvard architecture versus the von Neumann architecture. The von Neumann architecture can actually puts ROM and RAM in the same place, I believe. It's a data. You'd have two data buses going from the CPU to the RAM, and then the ROM for the Harvard architecture, and there's going to be one for the von Neumann architecture. And most general purpose operating computers, I guess you could say operating systems, use the von Neumann architecture. Yeah. There's still read-only stuff, but you have to tell the computer that this area or this segmentation is only read-only. I don't know how that works, but it talks to the kernel, and the kernel knows which particular parts of memory, even in virtual memory, of what the kernel would know what the different, because if you're, I don't know, if you're saying like const something in like C or something, then the compiler would then somehow compile that, and it would tell the kernel that, hey, this is read-only memory, and yeah. And then it would, it'd be translated to binary somehow. I don't know. Like there's a flag probably for it, and yeah. That seems interesting though. Yeah, and I had to play around with tool chains every once in a while because, again, like if you're messing with a bunch of CPU architectures, you had to get them online, of course. And I always use the ARM website because I only played around with ARM microprocessors when I was messing around with development boards. And I didn't make a project out of it. I was just messing around. Um, I made an LED blink. That was cool, I guess. I wish I did more with it, but I think the only reason I didn't do more with it is because my space is really small, and for me to do anything more complicated than that, I'd rather have a workstation, like an actual workstation, like a garage or a workshop, or maybe a makerspace of some sort. Then I'd probably play around with more hardware, but I don't have space for that. I don't know of any other places, but maybe I'll do research on finding maker spaces and whatnot. But yeah. So, anyways, I'm just blabbering again. So, yeah. And I'm talking about trivia stuff. I think trivia is fun. But yeah, yeah, I was like, I used to read about OS stuff and read about it, like, yeah, I would parse it and have, like, I still don't, I wouldn't say I know it deeply, but yeah, I wouldn't say I'd be necessarily interested in that, but again, for me, it would probably be games, and maybe I'll look at compiler stuff, and I've always wanted to get a book on compilers, or at least do a little bit of research on that, and I just like reading about stuff like this, and so yeah, I'll probably look at that too, and yeah. I don't know, I was talking about the compiler toolchain. I hope that made sense. They're basically compilers that are just made for particular computer architectures, obviously. Yeah, I mean, like, there's a slew of different computer architectures. One of those is x86 64, and then you have like RISC versus 6, and then I think the ARM uses RISC. I think it uses RISC. Maybe CISC. I think it may be CISC, because I think if you're using a CISC, the instructions are a little bit more complicated, meaning that you'd have less instructions, and it would have to be compact divided into a 32-bit, so you'd have to have at most 32 instructions, and it may be CISC, actually. So, I don't know. Maybe I'm wrong. ARM use CISC? I'm just going to ask, because computers are so cool, I guess. My Wi-Fi is not working. It's one of those two. Who cares? I care, but I can't get myself to look at it right now. But there's something wrong with my Wi-Fi. It tends to just randomly not work for whatever reason, and I turn it off and turn it back on again, and it starts working again. Like a lot of things, and when it comes to technology. Oh, Jesus. Okay. I can't wait for my computer, or my monitor and my keyboard, my two monitors, because I paid for a Dell 255H monitor yesterday. It was about $140-ish. That's after, the fees that they add. I had free delivery through Amazon. And yeah, it'll be coming in the next couple of days, and it has it can rotate. It has a swivel on it, I guess would be, yeah. Yeah. Oh, it's reduced instruction set computing. That's what they mean. Okay, the RISC is reduced. Oh, that's what they mean. Okay, so reduced instruction set, that means just less instructions, not the other way around, I think. Whereas the complex ones, that means you have an extended set of computer instructions. I was thinking about if it's more complex, and that means it would be less. I don't know why my brain was thinking of it like that, but that's what I was thinking at that given in time. So yeah, I don't know. I don't know. I just like CPU stuff. I like low level stuff. Yeah. So yeah. So that's basically what GCC toolchain is. It's basically. I think I explained it well enough. And the GCC toolchain has basically all of the other commands that you from the terminal that you'd be able to use, like objdump. There's of course you have the standard GCC command. Then you have There's like string something, and then there are a bunch of other stuff that are under GCC, aside from the actual compiling. There's objdump and I think they had like a bunch of other terminal commands that are used for inspecting ELF, which is executable and linkable format. So yeah, I think objdump actually looks at binary and it just spews out the ELF or some shit like that. I don't know. I haven't done that in a long time. Yeah, so cool stuff. Cool stuff. Yeah. I still don't explain that well. Oh well. I keep getting sidetracked. I don't know how to explain things well. I literally, I don't know. I just spew random shit out. I'm just saying whatever's in my goddamn head at a given time. Yeah. I may have to look at this video and see if I made any sense in any of these segments of thought threads that I had. Thought threads. I don't know why I say it like that. Yeah. Yeah. I think I don't know what else to talk about. I'm thinking about like what I was thinking earlier, and I just can't remember everything that I thought about because obviously that would be impossible for my head. My hands are clammy for whatever reason. I'm always anxious for some reason. Yeah, I don't know. I was also looking. It's like okay, so I'm starting to I'm still honing in on one possibility. Yeah, and yeah, I'm gonna focus on actually writing more, like actually focusing on a project and whatnot. And I am. It's just like I tend to get sidetracked a lot, and I'm annoying at times. I don't know. I don't like the brain that I have, but I have it, and I'm relatively on track for where I want to be in my life. And that involves low-level programming, learning C, C++, and maybe a little bit of Rust, because Rust is very popular in the low-level world nowadays. People love Rust because it's a lot safer than C, at least. Potentially C++. I think C is safer than C, and Rust is safer than C++ and C. Maybe it's just as safe as C++, but not as complicated. Maybe it's just easier to read, or people maybe just like the syntax or whatever. I don't know. I haven't read into it much, but yeah, so yeah. And I don't really know what else to talk about. Nobody's gonna listen to this video. Oh well. Bye.